Tech Talks Education. Let us continue with our electrical energy and chemical reactions, or what we call electrochemistry. So we have been looking at an electrochemical cell with the components or the features looking exactly like this, only that I have added some few things here. I have added, as you can see, the polarity or the charge sign on each electrode. We have also added the direction of the flow of current and the direction of the flow of electrons, as we can see. So we said that zinc is more reactive than copper, and in this case it behaves as a metal it is a metal which is more reactive. So since it is more reactive, that means that it can behave like a metal better than copper in this case, and metals behave or reacts by losing electrons from their outermost shells. Now the fact that zinc is more reactive than copper, it will lose electrons from its outermost shell or from the outermost shells of its atoms more readily than copper. That's why we say that at the zinc rod we shall have, let us have it somewhere here, at the zinc rod we shall have the zinc atoms losing electrons equal to the valence of zinc, which is 2, to form a divalent zinc ion, which is divalent cation of zinc ion. 2 electrons are lost. So this is the reaction at the zinc rod. We said that the electrons will have to flow through the connecting wire up to the copper rod, and in effect current flows but in the opposite direction. So the flow of the electrical energy through this connecting wire and through the voltmeter will make the voltmeter to show that there is some PD which has been developed between the two rods in this case, and then it will show a deflection. So when it shows a deflection, it means that there is some electrical energy which has been generated. So, and then we saw that when zinc rods, when the zinc atoms of the zinc rod loses electrons and the electrons reaches the surface of the copper rod, then those electrons will not be accepted by the copper atoms. There is what we call electronegativity which takes place here. Electronegativity is the tendency by a substance to gain electrons. In this case, we say that the zinc rod becomes more electropositive and loses electrons more readily. So electropositivity is all about the tendency by an atom of an element or by a substance to lose electrons, and here there is electronegativity which involves electron gain. So the electrons flow and reaches the surface of the copper rod, and on reaching the surface of the copper rod, they are accepted by the cation of the electrolyte. In this case, it is the hydrogen ions of the dilute sulfuric acid which gains electrons, and hydrogen gas is produced. Now, there is what we call polarization effect that we need to look at as a consequence of the production of hydrogen gas bubbles. So let us look at polarization effect. So we shall have, provided that there is continued flow of electrons, there will be continued reduction of the of the hydrogen ions of the dilute sulfuric acid, and then there will be the constant generation of or production rather of oxygen gas bubble, hydrogen gas bubbles. So sometimes the hydrogen gas bubbles accumulates on the copper rod here. As you can see, we may have the accumulation of the hydrogen gas bubbles on the copper rod. So the whole of the surface of the copper rod will be filled or will be full of hydrogen gas bubbles. So in this case, when the hydrogen gas bubbles accumulate on the copper rod, then the hydrogen gas bubbles will prevent the hydrogen ions of the dilute sulfuric acid from receiving the electrons, because we already have something that blocks the hydrogen ions from picking the electrons from the surface of the copper rod here. So the end result is that there will be the suppression of the flow of electrons, because we expect electrons to move here and reach here and reaching here, they are constantly supposed to be picked by the hydrogen ions of the dilute sulfuric acid. But if those electrons cannot be picked by the hydrogen ions of the dilute sulfuric acid, that means that they will have to accumulate here because they cannot be accessed by the hydrogen ions because of the presence of the bubbles of hydrogen gas. So that means that there will be a resistance to the flow of electrons from the zinc rod to the copper rod. And that means that less electrons will flow, and in effect, less electrical current will also flow. And then we shall see the pointer of the voltmeter trying to what? To deflect back to zero. That means less electrical energy will be able to flow. And we say that the whole cell has been polarized. So let us look at that. So when hydrogen gas bubbles accumulates on the copper rod, and our copper rod is the cathode, although it is positive, having a positive charge. It prevents hydrogen ions of the sulfuric acid from picking the, or from accepting the electrons produced from the zinc rod. So in effect, less electrons, hence electrical current or electric current flows, and the pointer of the voltmeter deflects back towards zero, and the cell is said to be polarized. And the cell is said to be polarized. Said to be polarized. So in this case, that's what we call the polarization effect of the hydrogen gas bubbles. So these bubbles prevents the electrons from being accepted by the hydrogen ions of the 2 molar sulfuric acid. So if they accumulate here on the copper rod, that means that less electrons will have to flow because there will be a resistance to the flow of electrons as a result of a high concentration of the electrons here on the copper rod. There will be no continued removal of the electrons. So less electrons will flow, and even in effect there will be less current flowing. Electrical energy will be less, that will be passing through the voltmeter, and we see the point of the voltmeter deflecting back towards zero, and we say that the cell has been polarized. Then the polarization effect of the cell is corrected by dipping the copper rod having the hydrogen gas bubbles in copper to sulfate solution. That means that we remove the hydrogen gas bubbles by dipping the copper rod which is having the hydrogen gas bubbles in copper to sulfate solution. Let us see a simple reaction that takes place. So we have hydrogen gas on the rod of copper, on the copper rod. So if you have copper to sulfate and you dip that copper rod bearing the hydrogen gas bubbles in that copper to sulfate solution, then there will be displacement in this case, whereby we shall have hydrogen being more reactive than copper, displacing copper from copper to sulfate solution. And therefore we shall get back to the electrolyte, which is dilute sulfuric acid. Dilute sulfuric acid will be produced together with the same electrode, which is copper, will also be formed. This one is just a simple displacement reaction, whereby in this case hydrogen will displace copper from the copper to sulfate solution, and in this case we shall get dilute sulfuric acid and copper will be deposited, which is the same electrode being used in this case. So that is how polarization effect can be corrected in an electrochemical cell. So that's what we call the polarization effect. Thank you for watching this Step Talks Education.